Hi everyone, welcome to the topic of differentiation. In the first part of the series, we're going to go through a quick introduction to what's differentiation and chain rule all about. So if you're ready, let's grab a pen and paper and jump right in. Previously, in order to find the gradient of a line, all we need to have is two coordinates. We can then get the gradient of a line by finding y2 minus y1 divided by x2 minus x1. How about the gradient of a curve? It's not that straightforward though. We can find the gradient of a curve at a point by drawing a tangent line to that point and obtaining the gradient of that tangent, something like you see in the diagram over here. However, on the curve, there are numerous points which gives us different values of gradients. So this is where differentiation comes in. The gradient of a curve at any point is given by the gradient function called dy over dx, something that we need to find. And the process of finding dy over dx is called differentiation. So by getting dy over dx, or in other words, by differentiating y with respect to x, we get a generic gradient function of a curve. So how do we differentiate a particular function? Let's take a look at an example over here. We are going to differentiate y with respect to x. Y is equals to 4x squared. So what we can do is to introduce this term, dy over dx. It means that we are differentiating y with respect to x. Look at the power, which is 2. Multiply the power to the coefficient of x, which is 4. And minus 1 to the power. So 2 multiplied by 4 is 8. And x to the power of 2 minus 1. Remember, multiply the coefficient minus 1 to the power. And this will give us 8x power 1, which we normally write as 8x. So let's try out some examples so that we can solidify our foundation. Differentiate the following with respect to x. We have part A, y is equals to 4x squared plus 3x. So we can start off by writing dy over dx is equals to, remember, multiply the power to the coefficient of x, which is 8, and minus 1 to that power. So we will have 8x power 1. And for the next term, we have the power of 1. So multiply 1 to 3, we will have 3. And minus 1 to that power, we will have x power 0, which is equivalent to 1. So therefore, we have 8x plus 3. In part B, you realize that y is not present in this expression. But not to worry, what we can do, or how we can write it, is d over dx, x cubed minus 5x squared plus 2x minus 3. And we can then start to differentiate term by term for this expression. So let's do the same method again. Multiply the power to the coefficient. So we have 3x squared minus, multiply the power to the coefficient, 2 multiplied by 5 is 10x power 1 plus, and we have 2 x power 0, which gives us 2, and minus 3. Now minus 3 has x, which has a power of 0. So what we do is to multiply 0 to 3, and this gives us a value of 0. So this will not be written at all in the expression. So your final answer will be 3x squared minus 10x plus 2. Now the third part looks a bit complicated. Not to worry. What we can do is to divide x on every term in the numerator. So we will have x squared divided by x, which gives us x. 2x divided by x gives us 2, and 1 divided by x gives us 1 over x. So we will have this expression, y is equals to x plus 2 minus 1 over x, and this is equals to x plus 2 minus x to the power of minus 1. Now I have converted the third term as x to the power of minus 1 so that we can manipulate this easily when we differentiate the term. So starting off with dy over dx, we will have power 1 multiplied to the coefficient, which is 1, and 1 minus 0 would give us x power 0, and we will be left with 1. Next, we will have minus 1 multiplied to minus, so we will have positive x, minus 1 minus 1, which will have minus 2. Therefore, dy dx is equals to 1 plus 1 over x squared. Now, just a quick tip for you. Differentiating 2x, which has the power of 1, is equals to 2. If you have 50x, if you differentiate it, we will have 50, so on and so forth. If we have half x, if you differentiate it, it will be equals to half. Similarly, for differentiating a constant term, such as 2, the value of dy dx is equals to 0, because x power 0, when you take the power, you multiply to the coefficient, it is equals to 0. So differentiating constants such as 502 or 1/4, for example, will all give us 0. So in general, if y is equals to ax to the power of n, where a and n are constants, if you want to find dy dx, all we need to do is to take that power, multiply to a, which is the coefficient of x, and minus 1 to the power. Alright, but if y is not present in the expression, what we can do is to put d over dx, copy the expression into your answer, ax power n, and that will be equals to a n x power n minus 1. Now, what if you need to differentiate this function? Y is equals to 4x squared plus 2x to the power of 6. Now, we will need to expand using the binomial theorem, but it is very, very tedious to do so. Therefore, we will use the chain rule to help us differentiate more complicated functions such as this. The chain rule goes like this. dy over dx is equals to dy over du multiplied by du over dx. Now, using back the example y is equals to 4x squared plus 2x to the power of 6, let's try to use the chain rule to help us differentiate this expression. Firstly, let u equals to 4x squared plus 2x, the expression within the brackets, and let y be equals to u power 6. Let's differentiate term by term, starting with u. So du over dx is equals to 8x plus 2, and dy over du is equals to 6u power 5. By applying the chain rule, dy over dx, which is equals to dy over du multiplied by du over dx, is equals to, let's try to substitute whatever that we have found previously, which is 6u to the power of 5, open a bracket, 8x plus 2. Simplifying further, by substituting u as 4x squared plus 2x, we will then have 6, open a bracket, 4x squared plus 2x to the power of 5, and 8x plus 2. Let's factorize 2 from 8x plus 2, and we will have 12, 4x plus 1, and 4x squared plus 2x to the power of 5. So this is the answer when you differentiate y equals to 4x squared plus 2x power 6. So the example that I've shown you is still quite tedious, so I'm going to show you a faster way to apply the chain rule using this example where we're going to differentiate y with respect to x. So in this question, y is equals to 5x cubed plus 2x to the power of 4. What we need to do is to take that power, multiply to the front of the bracket, which is 4, 5x cubed plus 2x, and minus 1 to that power, which is 3. So we will have dy dx is equals to 4, 5x cubed plus 2x to the power of 3. And the last step is to differentiate whatever terms within the bracket. In this case, it is 5x cubed plus 2x. So therefore, when we differentiate all these terms, it will be 15x squared plus 2. So bringing them together and rearranging the terms, we will have 4, 15x squared plus 2 multiplied by 5x cubed plus 2x power 3. This is how we can differentiate it quickly using the chain rule. Now, when do we actually use the chain rule? So from the above examples, the expression takes a certain format. Identifying this format is key to know when to apply the chain rule to differentiate an expression. So here are some examples where you can use the chain rule for differentiation. So you must have a function within the bracket without any variable outside the bracket, with a power on top as well. There is one example where we should not be using the chain rule, and this is where you have a variable just outside the bracket, such as this. We can actually use another rule for this, as there's a variable outside the bracket, and this will be shared in a separate video linked in the description below. Now let's try out two examples to solidify our concepts for chain rule. So let's differentiate the following with respect to x. We have y equals to 2x squared plus 3x minus 1 to the power of 3. Now how do we know that we can use chain rule? We have an expression within the bracket that has a power of 3, and there are no variables outside of this bracket. Alright, so starting off, dy dx is equals to, multiply the 3 to the front of the bracket, copy down the entire expression within the bracket, which is 2x squared plus 3x minus 1, close the bracket, and take 3 minus 1, which is power 2. Finishing it off, we will need to differentiate the terms within this bracket. Therefore, it will be 4x plus 3. So the final answer would be 4x plus 3 multiplied by 2x squared plus 3x minus 1 to the power of 2. Now we have another example that we can use to apply the chain rule. So this is actually y equals to square root 4x squared minus 5. Let's try to change this format so that you can see it better. So we will have y equals to 4x squared minus 5 power half. We can use the chain rule to differentiate this expression by writing dy over dx is equals to, multiply the power to the front of the bracket, which is half, 4x squared minus 5 to the power of minus half, because we have taken half minus 1, which gives us a power of minus half, and differentiate the terms within the bracket, which is 8x. Alright, so by simplifying further, we will have 4x multiplied by 4x squared minus 5 to the power of minus half. By rewriting the answer, we will have 4x over square root 4x squared minus 5. So there you have it. This is the chain rule. So in general, for the function y is equals to u power n, where there is an expression within u, such as a bracket. Alright, so dy over dx is equals to, multiply the power, which is n, to the front of the bracket, n u and n minus 1 multiplied by du over dx. Now I do hope you have learned something from this video. Do check out the free practice questions and worked answers that are linked in the description box below. I hope you have a good time practicing differentiation, and see you in the next video. Thanks for watching.